10 day 1, we are going to focus on the inverse of matrices and something called the identity matrix. Okay, so by the end of today, you're going to be able to find inverse matrices and understand identity matrices. So we're going to define those identity matrices. Okay, which play the same role for matrix multiplication as the number 1 does for ordinary multiplication. So there's a multiplicative inverse and there's an additive inverse. Okay, if something is an inverse, then you're going to get the same value back. So the additive inverse is what you add to a number to get itself. So what would you add to A if you want that to be your result? 0. Okay, so 0 is the additive inverse. The multiplicative inverse, what would you multiply by A so that you'd get itself? 1. Okay, so A times 1 is the same thing as 1 times A, and that would equal A. So the multiplicative inverse has to be commutative. Okay, so A times 1 and the 1 times A for all numbers A. Okay, and then our inverses are going to be square matrices. So a square matrix, okay, is one that has the same number of rows as columns. So a 2 by 2, 3 by 3, 4 by 4. Okay, and then the main diagonal of the square matrix consists of the entries whose row and column numbers are the same. Okay, and the entries are going to stretch diagonally down the matrix from the top left to the bottom right. Okay, and the identity matrix, I sub n, is the square matrix, so the n by n matrix, for which each main diagonal entry is 1 and all other entries are 0. So let's go ahead and see what these look like. So for I2, it would be 1, 0, 0, 1. That's the identity matrix. Okay, for the 3 by 3, you'd have 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so the main diagonal consists of 1s. Okay, and then the other entries are 0. So this would be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, so those are the first 4 identity matrices. Okay, and these behave like 1 in the sense that if you were to multiply some matrix A by its inverse, you would get that same matrix. Okay, and if you were to take that identity matrix and multiply by B, okay, you would get the matrix B. So again, it doesn't matter in this case what side you multiply on. And that's important because we learned last week that multiplication is not commutative. Okay, so I'm going to have you guys multiply the following matrices by their appropriate identity matrix. It's the appropriate identity matrix is always there for you. Okay, so you're going to multiply the identity times A, and we're going to verify what we get. So remember from last week, if it's a 2 by 2, and this would be a 2 by 3, your result is a 2 by 3. So if you're trying to find the first row, first column, first row, second column, first row, third column, we take the first row, which is 1, 0. We multiply it by the first column, that's 3, -1. Okay, and then your result, 3 plus 0 is going to be 3. Okay, and then this is the way I like to do it. I like to put the 1 and the 0 here, and then I like to plug those in. Okay, so my second column is 5, 2. My third column, coincidentally, is 6, 7. Okay, and then for this, 5 plus 0 is going to be 5. 6 plus 0 is going to be 6. Okay, so then your first row, 3, 5, 6. Okay, now when you're doing the second row, you guys can decide how you want to write out your work. I showed you that method because I can do that the fastest. Oops, C22, C23. Okay, but if you'd rather write out the products, that would be fine too. Okay, so go ahead and write out your multiplication and then we'll verify that. Okay, so if you wanted to write it out with the products, then if you do 0 times 3, you get 0 plus 1 times -1. Okay, so you have -1 here. So I don't care how you write out your work, just as long as you're showing that. So 0 plus 2 is 2. Okay, 0 plus 7. Okay, and then 3, 5, 6, -1, 2, 7. Yay, they work. Okay, and then in the 3 by 3, you'd have a similar case here, but this is where you have your matrix on the left, and then you're multiplying by this one on the right here. Okay, so it's a 3 by 3 and a 3 by 3. So we know our result is going to be a 3 by 3. Okay, so like I said, you can choose how you want to write this out. So if you do C1, 1, notice here it's just -1 times 1. The rest are going to be zeros. For C1, 2, you have a 0 to start with. This becomes 7, this becomes 0. And then for the 1, 3, it's 0, 0, and then the 1. So the 1/2, that's how you're getting the same values. It's because you have those zeros there that are going to leave you with one of your values. Okay, so for the identity ones, I actually might write it out using those. So my second row, I have 12 plus 0 plus 0, so it's going to be 12. For the 2, I have a 0 and a 0. It's just going to be the middle one. Okay, and then for the last one, you have the 0, the 0, the 3. Okay. And for this, you're multiplying using that value. That's also, sorry, we have the 1, 3, 1, 3, 2, 3, 3. Okay, so if you do the first one, it's just -2, because then you have the 2 zeros. Okay, for the second one, you have the 0 and the 0. The middle is going to be 0. Okay, and then for the last one, you have the 2 zeros to start. Okay, so yes, when you multiply matrices by their identity, you are going to get the same thing. Okay, so from that example, we know that we get the same matrix, and that's just like when we multiply a number by 1, we get the same number. All right, now we are going to be finding the inverse of matrices. Okay, so for the inverse of a matrix, if you let A be an n by n matrix, if there exists an inverse to that matrix, it's going to hold true to this property, okay, that a matrix multiplied by its inverse would be equal to the inverse multiplied by the matrix, and that would be equal to the identity matrix. Okay, so explain what this means in words. I just did that for you. So when you multiply a matrix by its inverse, what is the result? The identity. Yes. Yes. Okay, so if we are trying to verify that B is the inverse of A, okay, and they give you a value for A and they give you a value for B, we just have to show that when we multiply A times B, and when we multiply B times A, that's going to be the identity matrix for a 2 by 2. Okay, so the first one we're going to do by hand, then the next one I'm going to show you how to verify it on a calculator. Okay, so for A times B, we're doing 3, 2, 4, 3, multiplied by 3, negative 2, negative 4, 3. Okay, so if it's a 2 by 2 and a 2 by 2, we know the result is a 2 by 2. Okay, so all we have to find here is the C11, the C12, C21, C22. So like I said, for me, it's the fastest for me is to take the row, because I know I'm going to be using that row twice. And then here it's row 2, so it's 4 times something plus 3 times something. Okay, so that's how I do it quickly. And then I just plug in my columns. Okay, so if it's the first column, I plug in 3 and negative 4. This one's the first column, 3 and negative 4. This one's the second column, negative 2, 3. Okay, and this one's the second column, so negative 2, 3. Okay, I like writing it out and then doing the mental math. That's just easier for me. Okay, so we have 9 minus 8, which is 1. We have negative 6 plus 6, which is 0. We have 12 minus 12, which is 0. Then negative 8 plus 9, which is 1. So we have 1, 0, 0, 1. Okay, that is the identity matrix. But now we have to verify that B times A is the identity matrix. We're going to do this on our calculator. Okay, so we're going to tell our calculator what we want the matrices to be. And when we multiply, we do need to multiply them in this order. Okay, and then we're going to verify on our calculator that this is equal to the identity matrix. Okay, so on your calculator, we're going to go to the matrix, which is right above this inverse button here. Okay, so we're going to hit the second button, and then matrix lives above this guy, the inverse. Okay, so I'm going to go to second matrix, and then it gives you all these names. What you have to do is you have to edit. Okay, so we're going to arrow over to the edit so that we can edit what we want matrix A to be. So we're just going to press enter. So I want matrix A to be a 2 by 2. And then I am going to enter in my matrix A here, which is 3. So I can do 3 enter, 2 enter, 4 enter, 3 enter. So I have my 2 by 2 matrix, okay, which is A. Okay, and then I'm going to go back to the matrix. And once you go back there, you can see now A is identified. See, A is a 2 by 2. So now I'm going to go to edit, and I'm going to put in my matrix B. So matrix B is 3, -2, -4, and 3, and 3. Okay, I'm going to check that over. That looks good. Okay, so once you enter in the matrices, okay, then you have to quit. Okay, so you get to that clear screen, then you can multiply. Okay, so you go back to the matrix, and then what we're going to be entering in is matrix B times matrix A. Okay, so I'm going to go back to the matrix. Okay, I'm going to hit B first because I'm going to do B times A. That's what I have to do here. And then I'm going to go back to my matrix, press enter for A. Okay, and then we're going to multiply them together. And then did we get the identity? Yes, we did. Okay, so if we do get the identity, that means that B is the inverse of A. Okay, so because we got the identity matrix in both cases, B is the inverse. Okay, if one of these was not the identity matrix, then it would not be the inverse. Okay, and we can find what our inverses are. So when you are finding the inverse of a 2 by 2 matrix, you actually have a formula. So the inverse of a 2 by 2 matrix, if you are given a matrix, A, B, C, D are the entries, then you can find the inverse by using this equation. You have 1 over A times D minus B times C, and that gets multiplied by a different matrix. What happens is A and D switch places. So D is in the upper left corner, A is in the lower right corner, and then B and C become opposites. So B's an opposite, C's an opposite. Okay, now you can only find the inverse if that denominator doesn't equal 0. So if it does, then we know that the matrix does not have an inverse. Okay, so if you get 0 in the denominator, it does not have an inverse. And it's this value AD minus BC that determines whether or not there is an inverse. So that quantity we call the determinant. Okay, so it's the determinant of a matrix. And if the determinant is 0, okay, then the matrix does not have an inverse. Okay, so it is possible that it won't have an inverse because we can't divide by 0. All right, so if they give you this matrix, okay, your A value is 6, your B value is 4, your C value is 4, and your D value is 3. Okay, we can use our equation, so we're just going to plug in our values. Okay, so go ahead and plug them in for the fraction, and then see if you can plug them in for your inverse. Okay, so in the denominator, you have AD minus BC. Okay, so 6 times 3 minus 4 times 4. Okay, which is going to be 1/2, 18 minus 16. Okay, when you are making the matrix, D and A switch places. So if D is 3, it's now in the upper corner. A is 6, that's now in the lower right corner. And then these become the opposite. So all we have to do is distribute now, because this is a scalar multiple. Okay, so we just distribute the 1/2 to each. So we have 3/2, -2, -2, and 3. Okay, any questions for me about applying that formula? We understand what this means? The positions are switching. That's where this comes from. Okay. All right, then let's talk about how to find the inverse of something that is not 2 by 2. Okay, so if it's not 2 by 2, it's a little more complicated. Okay, so for finding the inverse of 3 by 3 and larger matrices, okay, we are going to use the following technique, which is the most efficient. So if A is an n by n matrix, we're first going to construct the matrix that's an n by 2n. So that just means it's a double that value. Okay, and it has the entries of A on the left and of the identity matrix, IN, on the right. So they give you this form that you can apply to many different situations. Okay, so the identity matrix is on the right. Okay, it's the matrix A on the left. Okay, and then they put this dash here. You are going to look at it all together, so I'm not going to write the dash when we talk about our goal. So whatever your matrix is goes here, whatever your identity is goes here, and then you use those elementary row operations to change the left side into the identity matrix, which is exactly what we did when we put it in reduced row echelon form. So we're going to use those elementary row operations to change the left side into the identity matrix. Okay, so like I just said, that means that we're changing the large matrix to reduced row echelon form. Okay, the right side is automatically transformed into the inverse. Okay, so you start with the given matrix, which we'll call A here, and the identity matrix is right next to it. Okay, there is going to be no separation. That's why it's twice as long. Okay, Okay, and then your goal is to have the identity matrix on the left and then the inverse on the right. Whatever you get on this right side is your identity. Okay, so once you do the transformation, you will be able to see the identity. Okay, there are a few fractions in this. I like to write those out on a piece of paper just because that helps me when the numbers get a little complicated. Okay, so if we're finding the inverse, we're just going to start with this matrix, 3, -8, 1, 1, -1, 0, 2, 1, 1. And then right next to it, we're putting the identity, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so all of those are together. Okay, so this is A. Okay, and then this is the identity. So just like we did last week with the reduced row echelon form, what's always our first step? What's our first goal? What do we want to get first? Yeah, we want to get a 1 where? Top left. Okay, so we could multiply all of these by 1/3. Okay, but let's try to avoid the fractions for a little bit if we can. What's an easier way to get the 1 there? Yeah, just flip-flop first and second row. Okay, so let's switch row 1 and row 2. Okay, so then 1, -1, 0, 0, 1, 0. Okay, and remember, part of this is keeping like a neat matrix. I do think that helps because when you have to look back and forth, having just your organized rows does help out. Okay, good. And then once you get the 1 in the top left, our next goal is to get what?
0 below it.
Yep, zeros below it. So last week I showed you how you guys could do that. You could do both of those in one step, right? You always want to use your leading 1. So we're going to do the opposite of, times row 1. We're going to do the opposite of row 2, and we're going to multiply that by row 1. So we want this to be -3, so when we add it to row 2, we get 0. Okay, and then we're going to put that in row 2. Okay, and then after we do that, and you can write that out, do it, and then you can think of the second one, or if you want to put them together right now, you can. So the opposite of 2 is -2. So we're still going to do the opposite of row 1, but now we're going to add that to row 3, and that's going to go in row 3. Okay, so I'm going to give you some time to do that right now. The what? Oh, yeah. All right, let's see how we did. All right, so the reason why we're doing that is because when you do -3 plus 3, you're going to get 0. Your result is going in row 2. Okay, and then you have 3 plus -8. What do we get there? Anya, what'd you get for the second blank? 5 or -5? Okay. Okay, and then Farrah, what'd you get for the third space? 1 is right. Okay, and then Ilaria, what'd you get for the next one? Yeah. All right, and then Kaya, what'd you get for the next space? It should be 1, 1, and then something else. So -3 times this one will be -3, and then when you add it to 0, you'll have the -3. Okay, and then Mira, what'd you get for the last one? 0. Yeah, great. And then if you know that you're just doing the R2 and R3, you guys can write the row 1 in first or last, whichever one you want. All right, and then so the reason why we do that is so that you can get the 0 here, okay? So -2 plus 2, this would be 2 plus 1 is 3. Brooke, what'd you get for your next space? 1. Jaden G, what'd you get for the next one? 0, good. And then Sam, what'd you get for the next? Right here, this space? -2. Yep. Okay, and then Lucas, what we get for that last one? Yes, great. Yeah. Okay, so now we have the 1, 0, 0. After you have the 1, 0, 0, what's your next step? What do you want to get next? So after the 1, 0, 0. Yeah, then you want to get the 1 here, okay? So now we're going to multiply by the reciprocal. So we're just going to multiply by -1/5. So that is a +1. And if that's all I'm changing, like I said, sometimes I'll just write these in first to keep them organized. Okay, so I have 0, I have 1, and then I'll have -1/5, -1/5, and then a negative times a negative, this will be +3/5, and then this will be 0. All right, and then again, if you're trying to get these two to be zeros, we can do those at the same time. Okay, you always want to use this leading 1, and really, with these, if you want, you can just add these two rows together. Okay, you can add row 1 plus row 2, and then you can put that in row 1. Okay, because 1 plus 0 is 1. -1 plus 1 is 0. 0 plus -1/5, -1/5. Same thing happens again. Okay, what's 1 plus 3/5? 8/5. So 5 plus 3 will be 8. And then 0 plus 0. It's okay. I'm going to start writing them out because with fractions, I need to write mine out. Okay, and then the other row that's going to change is row 3. So again, you need to use this row here. So we're going to do the opposite of row 2. So the opposite of what we want would be -3. So it'll be -3 times row 2 plus row 3. And we're going to put that in row 3. Okay, so this would be 0 plus 0. That's going to stay 0. -3 plus 1, that's going to be 0. Okay, and then so you have -3 here, -1/5. I did put sorry, -3 times -1/5. You have 3/5 plus 1. So sometimes I just write that out like that. Okay, so 5 plus 3 is going to give you 8, so then you have 8/5. Okay, so I'm going to give you a couple moments now to finish this row. Okay, do you guys need any more time for those 3 spaces? Good? Okay, Cedric, what'd you get for after 8/5? Yeah. And then Sam, what'd you get after that one? Yeah. And then Gabe, what'd you get for the last one? Yes. All right. Okay, so now what's our next goal? Now we have to get the 1. How are we going to do it? Yep. So we're just going to multiply by 5/8. 403. Okay, and when you're doing that, all you have to do, multiply by the reciprocal. The first 2 rows are going to stay the same. Okay, so we're doing 3/5 times 5/8. All right, and then Kinley, what'd you get for your next one here? So if you do the 3/5 times the 5/8, what will that give you? No. So if you do the 3/5 times 5/8, what's going to happen with the 5s? I like to write it out so I can see that they cancel. I know, but do it on your paper. Three over. So all you're doing is multiplying the 3/5 times the 5/8, right? Yeah. Yeah. Yeah, the 3/8. And then for the next one, you're just doing 5/8 times negative 19/5. Okay, so then Marjorie, what are we going to get for that one? Negative 19/8. All right, and then Jaden C, what are we going to get for the last one? Yes. Okay, and then do we know the last step? Can we write out what the last formulas are going to be? So write them out, and then the last row is already all set. Okay, so if you want this to be a 0, you just multiply by the opposite. So we're going to do 1/5 times row 3 plus row 1. We're going to put that in row 1. Okay, so the first few are pretty simple, right? 0 plus 1 is going to be 1. Okay, when you multiply here, 0 plus 0 is going to be 0. The whole reason why we did that is so we have 1/5 plus negative 1/5, that's going to be 0. Okay, the rest you might want to write your workout just on the side or on another piece of paper. Okay, so I'm going to give you some time right now to do that. Okay, so this is something that helps me when working with the fractions. This is obviously one of the harder examples because you have the fractions in here. So if you're doing 1/5 times row 3, okay, the first 3, like I said, those are pretty easy to do your mental math with. But for these 3, 1/5 times 3/8, and then I'm adding that row 1. So 1/5 times 3/8 plus a negative 1/5. Okay, and then I have negative 19/8 times 1/5 plus 8/5. And then I have 5/8 times 1/5 plus 0. So sometimes writing it out like this, I feel like is helpful. So then you can see it's 3/40 minus 1/5. So that would be 8/40. So what is negative 5/40 reduced to? Negative 1/8. Okay, so that's what's going to go here. Okay, and then for this one, you have negative 19/40. So we're just going to get a common denominator, times 8 times 8 plus 64/40. So 64 minus 20 is 44. So if it's 19, it'll be 45/40. So 5 goes into both. Oops, sorry, I put the 45 there too. So divide by 5, 9/8. That will be in your next spot. Okay, and then here I have the 5's cancel, so I just get 1/8. Okay, do you guys think writing it out like that helps with the fraction part? Okay, so now for this one, we want this to be a 0. So we're still doing 1/5 times row 3, but now we're going to add it to row 2, and we're going to put that in row 2. Okay, so I'm just going to do 1/5, 1/5, 1/5. Okay, and then for these, you have the 0 plus 0 is 0. 0 plus 1 is 1. 1/5 plus negative 1/5 is 0. And then this is where we have to pay attention. So I have the 1/5 times the 3/8. Then I'm going to multiply the negative 19/8. Then I'm going to do the 5/8. And then I have to add it to row 2. So let's see what's above it in row 2. Here I have negative 1/5. Here I have 3/5. Here I have 0. And then do you think that makes it a little easier to do than to try to keep track of all that in your head? So you have 3/40 minus times 8 times 8, 8/40, negative 5/40, negative 1/8. So I'm going to put that here. Okay, and then for this one, negative 19/40 plus times 8 times 8, 24/40. So I get 5/40, and that's 1/8. positive. And then here again, I get the 1/8. All right, and then once you have that, now you can see this is your identity matrix, right? This is the I sub 3. This is going to be your solution. Okay, so your inverse is negative 1/8, 9/8, 1/8. I tried to do the more difficult one in class and not as many difficult ones on the assignment. If you ever end up with a row of zeros on the bottom left of the matrix, okay, then there's no inverse. Okay, so if you end up with a row of zeros on the bottom, then there is no inverse for that value. Okay?